I am going to skip ahead to problem 11. So I'm going to skip ahead to problem 11.
Do you have the answers for the ones that you're...
Yes, would you like me just to tell you what the answers are?
Yes.
All right, I can do that. I don't have solutions written out, but I will tell you what the answers are. So, if I get a chance, I'll make recordings of them, but I want to make sure I get to the others. Okay, so the answer to number 6, we did 6, yeah, we did 6. So the answer to number 8, the supply voltage is 150 volts. I don't know what the angle is, well, that's coming up. And the phase angle is 60 degrees, is the angle between the voltage and the current. And that's what phi is, and the power factor is 0.5. And number 9, the voltages across the components are for the resistor, it's 50 volts. For the inductor, it's 86.7 volts. And for number 9, so it's A. A is 50 and 86.7. The phase angle is 60 degrees. And the real power is 250 watts. The reactive power is 433 VAR, or Q is 433. And the apparent power, S, is 500. And the value of the capacitor that is needed is 93 microfarads. And the new real power is the same. The new reactive power is 86.6, and the new apparent power is 263. If I have a chance, I'll go back and redo that one, because I think that one was a good one. It's just worded differently from the way he words things, so it's one of the reasons I'm going to do a different one instead in a minute. And for this one, the average value is 2 volts, and the RMS value is 2.31 volts. Okay, so now on to number 11. Can Zoom people, can y'all see my screen that has the problem on it, number 11?
Yes.
Okay, great. All right. So I have, I'm supposed to determine the complex power, apparent power, average power absorbed, reactive power, and power factor, including whether it's leading or lagging, for the load circuit is voltage and current at the given blah, blah, blah. Okay, so first of all, for A, do we have RMS or peak? Or what is our voltage as a phasor? 100 angle negative 30. And is that RMS? That's not RMS. So VRMS would be 100 angle negative 30 divided by the square root of 2. And IRMS would be 2.5 angle negative 60 divided by the square root of 2. And so our apparent power is going to be 100 over the square root of 2 angle negative 30 times the conjugate of the current, so that'd be 2.5 over the square root of 2 angle positive 60. And so when we multiply these, I will get 250 over 2 angle 30, which is 125 angle 30 degrees. And if I write this as, I take 125 angle 30 and I write that as in rectangular form, I get 108.25 plus J 62.5. And so once I have that, I know that my real power, so this is VA, my real power is 108.25 watts, and my reactive power is 62.5 VAR. And there's a couple ways to get my power factor, but one way is to say that it is the angle of my voltage minus the angle of my current. And so that would be angle of my voltage was negative 30 minus the angle of my current is 60. So that's minus negative 60 gives me 60. So that gets me 30 degrees. Notice that my current is behind my voltage, so this is lagging. And my power factor is the cosine of 30 degrees, which is 0.866. Any questions on that? Everyone see how to do it? Okay. All right. So the next one is easier. We have our voltage. It's already given in RMS, and so our apparent power is 440 angle 0 degrees times 0.5 angle negative 75 degrees. So that's 220 angle negative 75 degrees. So this one would be leading because our current angle is bigger than our voltage angle. If I take 220 angle 75 if you haven't yet heard my my praise of this particular calculator, the TI-36X Pro, it's fantastic. TI-36X Pro only costs about $20 and pretty much does everything you need it to do. And I find it the best of all the calculators including like my fancy $200 calculators, it's the best one for doing complex numbers. So if I take 220 angle what did I just get? Negative 75. And I change that to rectangular. And I get 56.9 minus J212. That's VA. So that tells me my power is 56.9 watts. My reactive power is negative 212.50 VAR. And since my reactive power is negative, that's another way that I know that it's leading. That negative power has to do with being, tells us it's a capacitive circuit and not an inductive circuit. Our power factor is the cosine of negative 75 degrees, and that I believe is 0.26, and it would be leading. Okay, so any questions on that one? Can you all see that corner of the screen? Yeah. All right. So I'm gonna save this one and then move on to number 12.